4.1, classify triangles and the triangle sum theorem. In Unit 4, relationships with triangles. As you'll remember, a triangle is a polygon with 3 sides. A triangle with vertices A, B, C is either called triangle ABC, or you might see it with the triangle symbol before ABC. Take a moment to pause the video and write down the key concepts below in your notebook. Now let's watch a video to understand why these are named the way they are, both by sides and by angles.
Hi, welcome to Math Antics. In this geometry lesson, we're going to learn all about triangles. You may remember from the lesson about polygons that triangles are special polygons that always have 3 sides and 3 angles. And that's what the word triangle means. Tri means 3, and angles means angles. Okay, that's easy enough. 3 sides, 3 angles. But what else is there to know about triangles? Well, for starters, we're going to learn how to classify triangles. Ooh, such a classy triangle. But seriously, there's 2 different ways to classify or organize triangles. They can be classified by their sides, and they can be classified by their angles. Let's start by classifying triangles by their angles, since we've already learned a lot about angles in the previous videos. You may remember from our first video about angles that there's 3 types of angles. There's right angles, acute angles, and obtuse angles. Well, watch what happens if we use a third line in each of these angles to form closed shapes. Aha! Triangles. And can you guess what these 3 different kinds of triangles are called? Yep. The one made from the right angle is called a right triangle. The one made from the acute angle is called an acute triangle. And the one made from the obtuse angle is called an obtuse triangle. So that's simple enough. But notice that for each of our 3 triangles, the new angles that were formed when we closed the shapes are all acute angles. So triangles always have at least 2 acute angles. And it's the other angle that determines what type it is. That's important to know so you don't get tricked. For any given triangle, just because you see one acute angle, that doesn't mean it's an acute triangle. You have to look at all the angles to tell if it's an acute triangle. The situation's easier with right and obtuse triangles because you can only have one right or obtuse angle per triangle. So as soon as you spot one of those kinds of angles, you know what type of triangle you have. All right then, classifying triangles by angles is pretty simple, but we can also classify triangles by their sides. If we pay close attention to the length of each side of a triangle, we can see that there's 3 possibilities. First of all, if all 3 sides of a triangle are exactly the same length, then we call it an equilateral triangle. It's kind of a long word, but it's easy to remember because it sounds like it has the word equal in it. To see the second possibility, let's take the top vertex of our equilateral triangle and move it up like this. See what happened? 2 of the triangle's sides got stretched by the same amount, but the bottom side remained the same. Now we have a triangle that has only 2 equal sides, and that's called an isosceles triangle. That's a long word too. The best way to remember that is to look at an isosceles triangle and say its name 20 times as fast as you can. And finally, to see the third possibility, let's move that same top vertex again, but this time to the left. Now, all the sides are different lengths. This type of triangle is called a scalene triangle. So those are the 3 possibilities when classifying triangles by their sides. Equilateral triangles have 3 equal sides. Isosceles triangles have only 2 equal sides. And scalene triangles have no equal sides. That way was pretty easy too. The hardest part is just remembering the names. And now that you know both ways to classify triangles, let's see how you can use them together. Yep, you can use them both.
Okay, so let's look at an example where a triangle has been graphed on the coordinate plane, and we're trying to first classify it by its sides and then determine if the triangle is a right triangle. So remember, if I want to classify something by its sides, it's either going to be scalene, meaning it has no congruent sides, isosceles, meaning it has two congruent sides, or equilateral, meaning it has three congruent sides. So what we need to do is we need to determine, are any of the sides congruent? And just by glancing, I think we can all probably agree that PO is not the same length as PQ or OQ. But we might ask ourselves, what about PQ and OQ? So let's go ahead and find the length of all three sides by using the distance formula. Just subtracting x minus x squared plus y minus y squared and taking the square root of the answer. So if we want to find OP, this would be this short side, although we might not need to find it. We would just plug in -1 minus 0 squared plus 2 minus 0 squared straight into our calculator, because all we really need here is a decimal approximation to compare. Okay, now let's find OQ. We have 6 minus 0 squared plus 3 minus 0 squared, and we get 6.7. So we can decide these are definitely not the same length, although our eyes kind of tell us that. Now let's find PQ. We're going to plug in 6 minus -1 squared plus 3 minus 2 squared and get 7.1. 6.7 and 7.1 are close to the same length, but they're not exactly the same length. So now let's figure out, what would we call this? Well, it has no congruent sides because none of the sides have the same length. So we would call this triangle a scalene triangle. And if we were to mark this triangle with its congruent sides, we might give this side 1 mark, this side 2 marks, showing these two are not the same length, and this side 3 marks, saying that this side is not the same as this and not the same as this. If we were to back this up and look at our definition of scalene, isosceles, and equilateral, you would notice that they have made one single tally mark to show that these two sides are the same length for two congruent sides, and 2 tally marks on all 3 sides to show that the 3 sides are congruent. So like tally marks means that 2 sides are congruent. Now that we've determined what kind of triangle it is, now we need to determine if it is a right triangle. Does it have a right angle? So what we wonder is this angle a right angle? That's the question, right? So this one is obviously not a right angle. And this one is also pretty obviously not a right angle, but different than this one. So we're really wondering about this angle. Well, remember that 2 perpendicular lines meet at 90 degrees. So if I could find the slope of this side and the slope of this side, I could decide if those 2 slopes were perpendicular, and if they're perpendicular to each other or opposite reciprocals of each other, then they would meet at 90 degrees, making this a right triangle. So we need to find the slope. Let's do that. The slope of OP, and maybe I should erase all my markings here. The slope of OP, this right here, can be found by doing y minus y over x minus x, 2 minus 0 over -1 minus 0, giving me a slope of -2. Okay, now let's find the slope of OQ. We have 3 minus 0, y minus y, over 6 minus 0, x minus x, giving me a slope of 1/2. R, -2, and 1/2 opposite reciprocals of each other? Well, they definitely have opposite signs. And if I take the reciprocal of 1/2, I get 2 over 1, which is 2. The other way we check to see if two slopes make a perpendicular relationship is to multiply them. If we multiply the two slopes or find the product of two slopes, then -2 times 1/2 is -1, just like we learned in a previous lesson, telling us that OP is perpendicular to OQ, and that angle POQ is a right angle. And so we could classify this triangle as both scalene and right. Therefore, triangle PQO is a right scalene triangle. We generally classify triangles as both their side and their angle names. The next thing we want to look at is the angles of a triangle. When we look inside the triangle, there are 3 interior angles. If we extend the sides of the triangle, we create exterior angles. First theorem, triangle sum theorem, says that the angle measure of the inside angles of a triangle add up to equal 180 degrees. Pause the video and write down the following information in your notebook. Now let's watch a video.
Okay, now that you know all about how triangles are classified, let's learn one more really important thing about triangles. In our video about angles and degrees, we learned that we can measure angles and say how big or how small they are using special units called degrees. Well, since triangles are always made up of 3 angles, each of those angles has its own measurement in degrees. And the important thing is that those 3 angle measurements, if you combine them, they will always add up to 180 degrees. For example, have a look at this triangle. If we were to take a saw and cut it up into 3 separate angles, and then if we were to take those 3 angles and rearrange them so that they're right next to each other like this, you can see that the total would be the same as a straight angle. That's 180 degrees. And this will work no matter what type of triangle it is. Knowing that a triangle's angles will always add up to 180 degrees can really help you out when solving geometry problems. There's a whole lot of situations where you'll know what 2 of the angles are, but you need to figure out what the 3rd angle is, like in this problem. With this triangle, we're told that one of the angles is 35 degrees and the other is 45 degrees. But the 3rd angle is unknown. We need to figure out what it is. Since we know that the total must be 180 degrees, we can just add up the angles that we do know, and then we subtract them from 180 degrees to see what's left over. The leftover amount must be the measurement of the unknown angle. So 35 plus 45 equals 80 degrees. And when we take that 80 and subtract it from 180, we get 100 degrees left over. That means that our unknown angle is 100 degrees. And you can always check your answer by adding up all the angles to make sure you get 180. So you can see why it's so important to know that a triangle's angles add up to 180 degrees. Well, that's all we're going to learn about triangles in this video. Remember, the key to really learning math is to do it. So be sure to practice by doing the exercises for this section.
Okay, let's look at an example. It says find the measure of the acute angles of the right triangle in the diagram below. Looking at the triangle, you can see the 3 angles are marked: 2x, x minus 6, and 90 degrees. So the first thing we want to do, if we want to find the measure of the acute angles, is to write an equation involving x. So we know that 2x plus x minus 6 plus 90 degrees has to equal 180. Step 2. Solve for x. When we combine like terms in this equation, we combine 2x plus x to get 3x, negative 6 and 90 to get 84, bringing down the 180. Subtract 84 from each side, and you get 3x is equal to 96. Divide by 3, and you get x is equal to 32. Once you solve for x, then you can find the acute angles. Coming over to this picture, I can see my two acute angles are 2x and x minus 6. So all I need to do is plug in my x to get my angle measure. Plug in my x to get my angle measure. And I could check my work by adding 90 degrees, the given angle, 64 degrees, the first acute angle that I found, 26 degrees, the second acute angle that I found, and making sure that this really does equal 180 degrees. And it does. Okay, moving on.
Consider any triangle and let's call it triangle ABC. We know what the internal angles are, but what are exterior angles of a triangle? It's simple. We just extend any one side. Let us produce side BC to point D, like this. Since we've just extended BC to D, it means that BD is also a straight line. That's it. This angle is an exterior angle. Angle ACD is in the exterior of the triangle, which is why it's called the exterior angle. We know that these three angles are interior, but this time we will look at them with respect to their exterior angle. First, let's look at this angle, angle ACB. We know that it lies in the interior of the triangle, and it is adjacent to this exterior angle. So with respect to this exterior angle, angle ACB is the interior adjacent angle. What about the other two angles, angle ABC and angle BAC? They too are both in the interior region of the triangle, but they're not adjacent to the exterior angle. They are called as interior opposite angles. Let's try to derive an interesting relation between the exterior and the interior opposite angles. Let's erase this and form a new triangle. Let's call it ABC. And we extend side BC to point D. For convenience, let us name the interior angles 1, 2, and 3 and the exterior one as 4. We know that the sum of interior angles of the triangle is 180 degrees. The sum of interior angles is angle 1 plus angle 2 plus angle 3. This sum should equal 180 degrees. And can you guess the sum of angle 3 and this exterior angle? What would measure of angle 3 plus the measure of angle 4 be equal to? If you notice the figure carefully, you will see that they form a straight line. Yes, they form a linear pair. Their sum would equal 180 degrees. Both these expressions equal 180 degrees. It means they have to be equal. We can say that angle 1 plus angle 2 plus angle 3 is equal to angle 3 plus angle 4. Subtracting the measure of angle 3 from both the sides, we can say that angle 1 plus angle 2 is equal to angle 4. If you noticed, angle 4 is the exterior angle and angles 1 and 2 are the interior opposite angles. This proves that the exterior angle of any triangle is always equal to the sum of its interior opposite angles.
Take a moment to pause the video and write down the exterior angle theorem that she just went over. The exterior angle theorem says that the measure of an exterior angle of a triangle, as you see angle 1 here in the diagram, is equal to the sum of the measures of the two non-adjacent or not next to interior angles. So in this diagram, you would see that angle 1 is equal to the measure of angles A plus angle B. In this example, it asks us to find the measure of angle JKM. So we're going to be looking for JKM, which is this angle right here. In order to do that, we have to begin by writing an equation that involves x and then solving for x. And we just learned that the measure of the exterior angle is equal to the sum of the two inside angles. So we can say that 2x minus 5 has to be equal to x plus 70. And then from there, we can simply solve. So if you don't remember how to do that, we would subtract x from each side. And that would leave us with, I'm going to have to come over to the side here, x, right, because 2x minus x is x minus 5 on this side is equal to 70. And then add 5 to get your 75. Once you've solved for x, then all you have to do is plug x back in order to find out what JKM will equal. So 2x minus 5 would be equal to times 75 minus 5, or 145, making the measure of angle JKM equal to 145 degrees. Go ahead and go to the quizzes and practice, and there is a quiz waiting for you. Good luck. I hope this made sense.